Hello, it's Corey again, and in this video we're going to talk about section 1.3, organizing categorical data. So why do we need to organize data? Well, raw data as it is collected, can be very messy, hard to read and understand, and also it's difficult to see patterns. So organizing the data helps us see patterns. So frequency tables. A frequency table is a table whose first column displays each distinct outcome, like right here, and the second column displays the outcome's frequency, or the count. So this is a frequency table that for people in the Titanic by ticket class. So we have first class with 325, second with 285, third with 706, and the crew has a count of 885. A frequency table records the totals and uses the categories names to label each row. And a frequency is the number of times the value is observed in a data set, or it's also known as the count. So relative frequency tables, they display percentages rather than the counts of the values in each category. So you can see this is now, the first class is now a percentage of the total number of people on that had that ticket on the Titanic. So how to do this would be to sum all these up, divide, and so we would divide 325 divided by all of the sum of all these, then multiply it by 100, and that's how you get the percentage by class. So I would recommend double checking to make sure that these percentages are right, because I think it would be very good practice for you. Two-way table shows how individuals are distributed along each variable, contingent on the value of the other variable. It displays two categorical variables and their relationships. So here's an example by the Titanic. So in revision, like in history, we would like to think that the lower social class, social economic class, died at a higher count than the higher classes, and you can see that's generally true, but we'll talk about how we can make that more correct. So this table shows how many times each combination of categories occurred. So each cell of the table gives a count for a combination of values for the two variables. So there are 528 third-class ticket holders who died, and then there were 673 crew class ticket holders that died. And then you can, so this top row would be that 212 crew ticket members survived. So you can interpret each row. Each row has an interpretation, so it's not too confusing. So here's some more practice, two-way tables and counts, and we're going to look at gender versus seatbelt practices. So not always means they don't always wear their seatbelt while in the car. Always means they're always wearing their seatbelt in the car. And then men and women. So how many women were surveyed? Well, you could, we look in this women column, add the total. So 3 plus 7 equals 10. How many from the survey always wore a seatbelt? Well, easy again, we just look at this always row, 4 plus 7, that equals 11. And how many women from the survey do not always wear a seatbelt? Well, this is really easy. We can look at the women column, and then we have to look in the not always column, and we can see that it intersects there at 3. So the bottom line is a frequency distribution of ticket class, and the right column is a frequency distribution of the variable survival. So 711 total people survived the Titanic, while 1490 died, and then this total is the number, like 325 first class tickets were sold, 285 second class tickets were sold, and so on. So two-way tables and percentages. Well, now it's asking what percent are men. Well, to our denominator is going to be the total number that we have in our two-way table. So 2 plus 4 plus 3 plus 7, that'll be equals 16. And then our top we're concerned with is just the percentage of men. So we want to count the total number of men, and it's 2 plus 4, that equals 6. 6 divided by 16 equals 0.375. And then to make it a percentage, we must multiply it by 100, and that equals 37.5%. And then another question is, what percent always wear a seatbelt? Well, our bottom still needs to be the total number in our two-way table. So 2 plus 4 plus 3 plus 7, that's 16 again. And then we need to look in the always row. And this is actually has a typo on it. It should be 4 plus 7, that's 11. And 11 divided by 16 equals 6.75% still. Just this, that 2 should be a 4. So percentages to counts. Of the 400 students who were surveyed, 65% were carrying their calculators, and of those carrying their calculators, 40% were men. So how many of these 400 students were carrying their calculators? Well, that's easy. You just multiply 400 by 0.65 and you get 260. And then how many female students were carrying a calculator? And this is a little bit more tricky, but all you have to do is multiply, well, take this number, because that's the total number of students that were carrying their calculators. Well, of those that were carrying their calculators, 40% were men. Well, that means 60% were women, so we need to take this 260, multiply it by 0.6, and we get 156. So here's an example. We should really only be concerned with this chart to answer these questions, but you'll see this part, this column right here, will add some more context behind. So there are more basketball injuries than football injuries. Yeah, I would say that's true, because 615,546 is greater than 387,948, so that's true. But is basketball the most dangerous sport among the 3 listed sports? Well, I mean, by counts, yes, it would be, but this can't be inferred from the data since we do not know the number of players in each sport, so that's why I said that the number of players would be important. So answer the following, true or false. So basketball is the most dangerous sport, so we simply just take the number of injuries in each sport divided by the players, and that will give us the rate of injury in a sport after multiplying by 100, of course. So in baseball, we get an injury rate of 1.15. And then in basketball, 615,546 divided by the number of players, which is 28,500,000, and we get multiplied by 100, and we get 2.16%. And then finally we go to football, 387,948 divided by 17,700,000, multiplied by 100, and it's 2.19%. Well, actually, so now we can infer that football is actually more dangerous than basketball from our data collected. So here's an example, 20.54 injuries per 1,000 people. We report not the percentage, but the number of events per 1,000 objects, or maybe even per 10,000 objects. So we call those such numbers rates. So 20.54 injuries per 1,000 people. That would be a rate of the number of injuries per 1,000 people. So complete the table, so the data shown is the number of citizens in the United States that have AIDS. So I'd pause the video and complete this column by dividing each population by 1,000, so this number by 1,000. And an easy trick to do that is just to move the decimal point 3 places. Alrighty, so you completed question 1. So we filled these in, we moved the decimal point left 3 spots, and we get 18,251, 2,904, or 23,904, 12,432, and 588. So now we can complete the AIDS per 1,000 population by dividing the AIDS number, so this number, by the population to get this rate. So by doing that, you'll get these numbers. So 65,582 divided by 36,553, and we get 1.79 per, so that's not a percentage, remember, that's just the rate. So the number of AIDS patients per 1,000 population rate. And then again, 48,059 divided by 18,251, that's 2.63, and so on. So now we can rank these by this rate, and so DC would become first, next would be New York, because it's 3.90 and it's higher than the rest of them. Third would be Florida. Fourth would be California. Fifth would be Pennsylvania, and sixth would be Texas. So in which state would you be most likely, or most or least likely to meet at least one person with AIDS if you randomly selected the 50? Well, DC has a much higher rate, so that would be the most likely. And then in Texas, it would be the least likely because it's got the lowest rate. So of the 50 random people, here's an official conclusion. Of the 50 random people in any one of these states, you're most likely to meet someone with AIDS in DC and least likely in Texas. And we just talked about that. So the government receives more of its total revenue from the middle class Americans than from the rich, so the rich are undertaxed. Well, here's a problem. There are many more middle class Americans, and the rich, actually the rich are actually taxed at a higher rate. So this is an example of a misleading statement. We could make this true if we add more context to it. So and then organizing and reporting categorical data, we want to use percentages or rates rather than counts when comparing groups with different sizes, as we saw in our football versus basketball and baseball injury rate. You can infer from that a lot closer by doing this rather than just looking at the total number of counts or frequency of injuries. And then we can also use a two-way table to display the results of a 2-question survey or a 2-outcome experiment. So on our next video, we'll go over section 1.4, and thank you for tuning in.